Hello friends, today I'm going to solve LeetCode problem number 2444, count subarrays with fixed bounds. In this problem, we are given an integer array nums and two integers min k and max k. So we need to find an array which has a fixed bound. That is, we need an array, basically a sub-array, where the sub-array consists of both the min value and the max value, and also the maximum of that sub-array should be the maximum value and the minimum should be the minimum value. Let's look at this example here. So let's take a sub-array. Let's suppose we take this sub-array. So what's the maximum value of this sub-array? 5, right? And what is the minimum? It's 2. So we got the maximum and minimum value. It's 5 and 2. But does it have this min value 1? It doesn't have this min value 1, right? It has this 5 but no 1, so this is not the sub-array, fixed bound sub-array that we are looking for. So what would be the fixed bound sub-array? The fixed bound sub-array would be the sub-array which has the minimum value equals to 1, the minimum, that is the value given by this integer, and the maximum value is equals to 5, which is given by this integer here. So this would be one of our sub-arrays with fixed bound. Then another bound we could create is this one, which also has the maximum value 1 and the minimum value is equals to 7. But when we include the integer 7 in this sub-array, what happens is now our maximum bound becomes equals to 7, so it exceeds the maximum value. So that is why that's not our sub-array. And next, when we look at this one, so basically we are actually splitting our array once we found a value that doesn't fall within this bound. So we have an array here, a sub-array here, and we are going to create a sub-array here, and we are now going to check, does it fall in the bound? Well, basically it has the minimum value, max value, but no min value, so it is not the sub-array that we are looking for. So one thing to keep in mind is that our sub-array must have the minimum and the maximum value which satisfies these two values, and if there is a value that doesn't fall within the bound, then our sub-array ends there and our sub-array starts from where the sub-array starts like satisfying the minimum and max bound. Now let's see how we could solve this problem. So let's first start with the brute force mechanism. So in the brute force, we are going to start with two indices, index I and index j. So we are going to loop over each of the value for index I and index j. So index j will be nested within this for loop, will be nested within this for loop. So now we start with the value of j that will be equals to I, and we here have the minimum value, right? This value satisfies the condition and it's minimum. So since we found our minimum, we mark this as true, and then we now increment the value of j points to this value. This again falls within our min and max k values, and next what we do, we increment the value of j, and this falls within the range of min and max, and also we found our max, right? So we found our min and we also found our max. Since we found both the values, this now becomes one of our sub-arrays, so our result will increase by 1. So initially it's 0, we increase it by 1. So what we do is we keep on moving. So now our j points to this value here, and since this also falls within this range and we have both min and max within this sub-array ranging from I equals to 0 and j pointing to this index, our result again increases by 1. Now we again increment the value of j, which points at this value here, which is 7, which has a maximum value greater than this max k. Since it doesn't satisfy the condition, what we do now is we go back, that is we break from our loop. So we break from this for loop for j, and then we go back to our while loop, our loop for index I. Since index I was at value 0, now the value of index I will be equals to 1. So now our index I is pointing to this index here. So I is pointing to index 1 is equals to index 1 pointing to this value. Now this value, of course, it falls in our range, right? Falls within our min and max value, and we have not. So far I is equals to 1 and j is also equals to 1. So both I and j point to the same pointer. So let this be our j here, and we don't have both. We haven't found min and max in this subarray, right? So what we do is we keep on going. Our j is now pointing to this value, our I is still pointing to this here. So now we found our max. So we found our max, and again we keep on moving because we still need to find our mean. So here we reached the value 2, and 2 is again falls within the range, but we don't have our mean yet. So we increment our value of j, and now this exceeds our bound. So what we do, we increment the value of I is now equals to 2. So our value of I equals to 2, and our value of j starts from where value of I starts from. So now j would start from index 2, that is this point. So here we again found our max. So what we do, we increment our j. Now j points at this value, it still falls within the range, but we haven't found our mean yet. So now we again increment the value of j. Now what happened is we again exceeded the bound. So now we again increment the value of I, which is now equals to 3, and now j also starts from index 3. So basically that's this point, and we have not found our max and mean yet for this range where I starts from 3 to j equals to 3, and we increment our j, and then we again fall out of bound. So we now increment our value of I, which should be equals to 4, which points at this index here. Since that's out of bound, we again increment the value of 5. Now it points at this index, and our j also points at this index. So we found our max, but we don't have our mean yet. And when we increment the value of j, we go out of bound, that is our index j is out of bound. So now we have the result I result, which is equals to 2. So we found our result. But following this brute force solution would mean that we are looping from I equals to 0 to n minus 1, and also j equals to 0 to n minus 1, right? So that would mean that our time complexity is n times n, that's n squared, which is a huge time complexity, and that leads to time limit execution in LeetCode. So what are we going to do is we are going to use a different approach to that is O of n time complexity. So let's see how are we going to solve that using the O of n time complexity approach. So for that purpose, what are we going to do is we are going to need the position of the mean, all right, and we need the position of our max value in our subarray, and this position should be basically the position of these values, min k, position of min k, and position of max k value. Initially we set all of these values to -1, so we have this value -1, and we also set a left bound which is equals to -1 initially. So what we do is now we start from index I, which points to the index 0, I pointing to 0. So we found our minimum value, right? So the position of minimum now becomes equals to the value at that in the index value of that. All right, so that would be equals to 0. So we found our minimum, which is equals to 0. Now what we do is we take the minimum of both our position of min k and position of max k. So what is the minimum of these two values? Since our min k is equals to 0, max k is equals to minus 1, so our minimum is equals to minus 1, right? Since minus 1, to update our result, we are going to take the value 0 comma the max and this value, and we are actually going to take the max of these two values. So we are actually only adding a positive number to our result. So if this number is positive, we add that to our result, but since it's negative, we don't add it to our result. So now what we do is we increment the value of I. Now index I points at this value here. So we already have our min k assigned to 0, and since it falls within the bound, so we do not do anything, we just increment the value of I, and now we are at this point here, which points to the value 5, which is equals to our max value. So our max position is updated to that value, which is equals to 2. So now we have our max, min and max value. So now what we do is we compute the minimum of these two positions, which would be equals to 0 comma 2. So that would result into the minimum value equals to 0. And now what we do is we take the difference of this min with our left bound. So left min minus left would give us the value equals to 1, because 0 minus 1 is equals to 1, right? So now we take this value, we actually take this value and find our, add it to our result. So result plus would be 0, maximum of 0, and the difference between these two. And since the difference, the max value is equals to 1, so our result is now updated by 1. So now our result is equals to 1. So next what we do is we again increment the value I, and now it's pointing at value 2, and still our min k and max k doesn't change, but we still have our left bound. We are still going to find our minimum, so that would still be equals to 0, and 0 minus left, which will be equals to 1, and again the maximum of these will be 1, so we add that value 1 to our result, and we keep on doing so. So now our value I is at this point, and since this is not within our min k and max k value, so what we do is we now update our left bound, the value of left. So this would be equals to the value at this index, which is equals to 4. So what does this mean is, okay, let me just give you one more example. So we now update the value of index I again. It points to index 5. So we found our max value, right? So now our max is at index 5. Again, now we calculate the minimum of these two values. That would be equals to 0, right? 0 is the minimum value, but the difference between 0 and the left bound is equals to minus 4, which is negative. So negative means we are not, this would also be minus 4. So 0 and minus 4 is equals to 0, so our result doesn't change. So what's happening here is, what does it mean by minus 4? So this left bound indicates that here at this left bound we found a value which was not within this bound, that is it was either less than 1 or greater than 5. Since that was the case, so we what happens is, for our subarray to form, any value should now our subarray, the minimum of both of these distances, I mean the minimum position of our min k and the minimum position of our max k should be greater than our left bound. So it should be more than our left bound. So any value min k and max k, both of them should be present to the left of this value here. That is only when we are going to find our subarray. So let's suppose if we had one more value here that was equals to 1. So in that case our max was updated to 5 because we had this value here, right? Now our min would be updated to this index that would be equals to 6. So our min would be equals to 6. The minimum of these two is equals to 5, right? Now taking the difference, 5 minus 4 would be a positive value equals to 1. So what we take is maximum of 0 and 1, so we'll add the value 1 because that's equals to 1, right? So what happened is we found our subarray here, right? We cannot take a subarray this which consists of the value 7, because then our max value in that subarray would be 7 and not 5. So that's how we are going to solve this problem. Let's now try to code it. So what we need is, we need to find the minimum, the position of minimum min k and position of max k, and we need the left bound. So let's first of all define our edge case, that is if min k is greater than max k, then we are going to return 0. Okay, now let position of min k equals -1, let position of max k equals -1, and let left bound equals -1. So everything is initialized to -1, and then our result is equals to 0. Now we start our loop from index 0 ranging until n, incrementing our value of index by 1. Okay, so if our bound value is not satisfied, that is if nums at index I is less than min k, or nums at index I is greater than max k, that is it falls out of this range, then this is when we update our left bound equals to I, and then we continue. That is, we do not proceed to our other part of the code. If it satisfies, then what we are going to do is we are going to check if it's equals to nums, the min or the max. If it is equal to min, then we are going to update the value of position. Okay, min position equals to I. If nums I is equals to max of k, then position of max k is equals to I. And then next what we do is we calculate our count. Okay, so that's the start. Basically this is the start of our subarray. So start would be equals to method min of position min k, position of max k. So beginning position POSIT. Okay, so once we found our start value, now we are going to add it to our result, the max of 0 and the difference between the start minus the left bound, so that if only this is positive, that is the start is greater than the left bound, that means that both the mean and the max lies to the left. That is when we found our subarray. So we are going to add to our result, and then finally we are going to return our result. Let's run our code and look for any errors. Okay, so we have an error. We did not define an. Okay, we have one more error. This is left bound. Okay. All right, we got an. Oops. So we have to update this by +1. Cool. Let's submit our code. Awesome. So now the time complexity, as I already told, it's O of n, and space complexity is constant.